Lesson 1.9 is on understanding scientific notation. We talked about scientific notation a little bit in lesson 8. We're going to go ahead over to page 58. So example 1, Louisa is researching the approximate distance between the Earth and the Sun. Her father told her the distance is 9.296 times 10 to the 7th miles. In an astronomy book, she found the following. Which distance is correct? Okay, so this is the distance that was in the book. This is what her father told her. So if you look at what's happening here, what happened is her father used scientific notation. So when we have really big numbers or really small numbers, we can use scientific notation, which makes it easier to compare numbers and say which one's bigger, which one's smaller. The deal is with scientific notation, for scientific notation, what we're going to do is we're going to put the decimal point right after the first non-zero digit. So the first digit that's not zero, right after that number is where we will put the decimal point. And then the other thing is we're going to count the number of digits after the decimal point to determine the power of 10. Like we talked about in the last lesson, if it's a big number, it's going to be a positive exponent because we'd have to multiply by 10. If it's a small number, it's going to be a negative exponent because we would have to divide by 10 to get to that. So these actually are the same. They are the same, just written differently. And this is an example of scientific notation. A little bit different than the last lesson because we have numbers after the decimal point. Last lesson we would have just we rounded it and it would be like 9 times 10 to the 7th power. This one we got 9.296 times 10 to the 7th power. So anything after the decimal that's not zero, you have to put it there. All the zeros at the end though, you can just forget about those. We don't need those for scientific notation. So if we look at the triad, the height of Angel Falls, the tallest waterfall in the world, is 3,212 feet. How do you write this number in scientific notation? Okay, and let me start by saying this number is not very big, so there's probably would not be one we would normally put in scientific notation, but we'll go with it. It's okay. So the deal is, like we talked about at the beginning, we want one number that's not zero and then the decimal point. So to get one number that's not zero and then the decimal point, decimal starting here after that last digit, we need to put it right here between the 3 and the 2. We want just the 3 and then the decimal point there. So then that would be 3.212. We still need those numbers back there. And then the question is what our exponent's going to be. So it would be to the 3rd power because we moved the decimal 3 spots. And again, multiplying by 10, every time we multiply by 10 moves our decimal 1 spot to the right. So multiply by 10, multiply by 10, multiply by 10. That's the same as multiplying by 1,000. Moves our decimal 3 spots over, gets us back to 3,212. Like I said, this is not a big number, so normally would not be doing scientific notation with it, but you can do scientific notation with any number technically. So example 2, we've got a little bit better example here maybe. What is the width of a red blood cell written in scientific notation? So we're looking at this number and it's kind of a blur of zeros. Like you have all these zeros and there's no commas in these decimal numbers, so it's hard for us to even look at that and like count how many zeros there even are. But what we've got to do then is we've got to get one number that's not zero and then the decimal. So the first place that happens is if we put it right after that 7. And then the question is how many spots did we move the decimal? So we moved it 1, 2, 3, 4, 5, 6 places. This is what I do normally, especially these ones with no commas in them. I mean, if you want to go by groups of 3 or something and count how many spots you moved it, that's fine. But do something where you're actually kind of physically moving it or looking at how many numbers you moved it across. So that moved 6 places, and so it'd be 7.03. We need the 03 because they're not all just zeros after that. And then that would be 10 to the -6 power. We moved 6 spots, but it's a small number. It's a negative exponent because it's a really small number in this case. So if we look at the try it, a common mechanical pencil lead measures about 5/1000ths of a meter in diameter. How can you express this measurement using scientific notation? Okay, so normally they don't put that in meters. But if they did, our decimal would have to go after the 5. We want one number that's not 0 and then the decimal point. So we'd have 5 times 10 to the -3rd power. -3rd again. We moved 3 spots, but it is going to be negative because, like we've mentioned before, we have to divide by 10 3 times to get it back to what it was. So example 3, Kelly used a calculator to multiply large numbers. How can she write the number on her calculator screen in standard form? So what happens sometimes is if you have really big numbers when you're working this out on a calculator, you might get an answer like this. Basically what that means is the numbers would not all fit on the calculator screen. So this is the same as 3.5 times 10 to the 15th power. That's what that means. Okay, it just wouldn't all fit on the screen, so that's why they wrote it this way. So this is how this could be written then in standard form. The book talks about standard form. They really don't tell you what it is, but standard form is just how we usually write numbers. So usually we don't use scientific notation. Usually we would write, for example, this number right here, that would be in standard form. That's how we usually write the number, okay? So then part B, they have another one, only this one's a negative exponent. So that would be like 8 times 10 to the -9th power. And then we just start here, move your decimal 9 spots to the left, add some zeros, and that would be how we would write that in standard form. So these on the try it, they're not giving us a calculator deal, but they're saying if this was scientific notation, what would it be in standard form? So for this one, there's our decimal. Times 10 to the 18th, we're going to move 18 spots to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And all of these will be zeros. And then since this is a big number, we'll have to put commas in here. Basically, we had to move 3 spots to get past the numbers that were not 0. And then we had to add 15 zeros onto the end of it. So that's what that number would look like. And then part B, this one's to a negative power. So we start out here to the -8th. We're going to move 8 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8. So in that case, 1 spot gets us past the 6 to the left of the 6, and then 7 more zeros. If you want to put a 0 before the decimal, you can.